So as JR said earlier, I'll be talking talks called Swift Without Swift, a React Native performance tale. He helped me come up with the name, so sorry about that. At the end of the talk, it might become a bit clearer. But what I'm going to talk to you about tonight is how to identify and target performance issues in your React Native app. And rather than kind of going all in, trying to sort of sort everything out at once, try and do it in a systematic way where you can track sort of what impact you're having with your changes and try and sort of make those new standards going forward as you're coding. So my name's Daniel James. I'm an architect at Theodo. We're an agile web agency based over in Farringdon. And the talk tonight is going to be based on experience working at Theodo, but most recently Force Markets, as Kagla was saying. We've done a lot of performance improvements there over the last month or so. So to set the scene, we've made it to the App Store. We've done a couple of hard months of work, which is great. This was 2 months ago, and we thought it was great. Okay, well done. It's time to take a holiday. But once that kind of giddiness wears off, you begin to realize that actually it's not as great as you thought it might be. You play around with the app a bit, and the shine begins to fade, and you're like, okay, what's happened here? Basically, it just feels a bit slow and a bit just isn't really what you're expecting. It works, yes, but compared to the other nice shiny apps that we're all used to these days, it's just not quite up there yet. You're showing it off to your friends, and you're just not that impressed with it anymore. So, what do you do? So you fix it. So there's no need to panic. You're not going to have to rebuild your whole app, I don't think. Most of the improvements we've made have been quite small code changes, and if you spread that through the whole app, then suddenly we within a couple of weeks we had a totally different performing app. So like I said, rather than just letting loose and saying, okay, I'm going to fix everything now straight away, I know what's wrong, you want to try and sort of systemize it a little bit. So you want to start with a benchmark. You want to know where you're starting at and whether you get better, whether you get worse. Then you want to actually identify where those largest bottlenecks are coming from. Then you want to fix them. And in fix them, you want to kind of share with your team, like, okay, don't do that again. That was, I don't know, you did something, a bad bit of code. And then after that, you want to re-benchmark and see where, after those changes, whether they had a 100% impact or whether they didn't actually have any impact at all. So it's that measurement cycle that helps you work out and kind of implement the best changes in the future. So as I said, the benchmark basically allows you to track the effects of the individual changes. It allows a team to work on the problem because each person can actually benchmark before and after their pull request, so that they can decide, okay, this commit here actually had a 10% improvement. We should look at that. And also it lets you work out how bad is it really actually. So we had quite a high number when we first measured the app, and I thought, okay, it doesn't actually seem that bad compared to other apps. So I compared it to some Facebook apps and other apps, and actually it helps you give a sort of comparison to other apps that you can download. So the benchmarks that we can use, so the obvious ones, you want your app to feel good when a user is using it. So you want that nice shiny feel, you want things to be sliding around. And that all boils down to, if your app is coming in at 60 frames a second, you'll have your smooth interactions and it will look good. But sort of measuring frames per second is a little hard. And then there's this notion of janky frames, which I hadn't heard of at all until working on this. But a janky frame is so for something to render at 60 frames a second, it has to fit inside its 16 millisecond allocation for that frame. And if it takes longer than it's allocated, then that's when you begin to notice frames being dropped, things start to look jagged. And that's any frame that takes longer than its 16 milliseconds is classed as a janky frame. So that's something you can measure. But maybe you have other problem that maybe the load time of the app isn't what you're expecting. Maybe you've got a big load of data you need to get in. That's something you could track. That could be your benchmark. If you've kind of reached a good level and there's only a few little parts of the app left, then you can get really in detail with the flame graph, and you can work out how long in, I guess, debug mode it's taking to render a component. And then you can, again, you develop based on that benchmark. And maybe if it's really powerful, you can start looking at the CPU, GPU usage from, I haven't got that far, so I don't know how you do it. So, but you could look at that. So the one we went for, we use is Janky Frames, because like I said, we were worried about how the app felt to users. So we were interested in how it's kind of sliding about, how things are opening, how they're animating. So before I move on, is the idea of a Janky frame clear? Yeah, cool. So to measure a Janky frames, there's not a perfect method for it yet. It kind of reminded me a little bit of a school science experiment almost, where you're kind of just measuring something, hitting the timer, stopping it, and it is it's affected by environmental conditions. So it depends the phone you're running on. If you're running on an old phone, the frame rate isn't going to be the same as if you're on an iPhone X. So it's a relative measure. It's not something you can go and compare to someone else's on a different phone, different app. Their Janky frame is going to be different to yours, so don't get too offended if you have two different numbers. But like I said, as long as we have an indicator that can basically tells us our trajectory, are we going up or are we going down? That's all we need. So relative to the project, this is proven to be a really useful measure. So the process we've come up with for measuring is you identify your key user journeys. So as Kaggle showed on SmartKits, that's maybe opening the app, scrolling to one of the top events and placing a bet. So that's the first one we decided to test. We found an Android test device, which is my phone. So that's why it's not iOS. So I think you can do exactly the same thing on iOS with different tools. And it's, as I said, it's important that's why it's imperfect as well, is that all the measurements have to be done on my phone to keep that relative measure the same. So there's definite room for improvement there. But then with the release build of your app, you plug it into your laptop. You clear all the other apps from your screen to give it the most kind of basically a controlled environment, so you're only focusing on your app. Then you start it, you run through a journey. So I log on, go down to the top market, and I place a bet. And then this thing where you're kind of pressing stop for the timer, you run this command, adb shell dump sys graphics info with your package name here, and that will then basically give you this rather ugly console dump of the stats it's taken about the graphics performance. So the really one interesting one for us is this Janky frames value here. So it's that journey that I just did, 20% of the frames didn't actually make their 60 frames a second cutoff. And believe it or not, that's actually, that was taken last week when the app was feeling quite good. So when we initially started, it was about 43 on my phone. So 19 isn't actually a bad number. So like I said, these numbers are relative. So once you have your first result, note it down somewhere. And this kind of where it starts getting fun, you can track basically where you're starting, and then as you go along, you can start adding your new measurements. And it becomes a little bit, you get a little bit excited over performance, which is sad, but it does happen. So you need to, once you have your measurements, you need to start identifying what's actually slowing your app down. So I'm not going to go into huge code details here because it's a rabbit hole and you could go down. We found loads of tiny little fixes that we wouldn't have thought of. But there's some of the big tools that we have used. There's a library called Why Did You Update? So it wraps around your React import, and in your console, whilst you're in debug mode, it basically tells you this didn't need to re-render, this didn't need to re-render. basically asking you, why did you update that? You can also use the Chrome flame chart. Like I said, it's more detailed. It's more the component level. So I wouldn't necessarily suggest starting with it. It is worth running through once to see if there's any obvious kind of component taking all your render cycles. We'll look at that quickly after. There's Firebase performance tracking, which we've just started implementing. It basically allows you to set traces, which are timers in your production app, and then Firebase will collect them from people's phones, and you can see how long this event you've chosen to measure actually takes. So you can actually start benchmarking on your real users' devices as well. And if you've cracked all of that, then there's some really kind of detailed stuff on frame stats and sysinfo stuff, which again, I haven't gone into yet because there've been too many easy wins with the first ones. So the two we went for were why did you update and the Chrome flame chart. So this is basically one result from why did you update. So we wrapped the React import in the why did you update module. Then you run it in debug mode, and basically probably when you first run it, your console will be flooded with this is updating, this updating, this updating. So it was actually unusable the first time we turned it on. So you can filter out, if you've got a hunch that it's all flat list, then you can filter out by the display name to only see the useful ones. So basically, so what it's told us here is that flat list props, the value didn't actually change. So in JavaScript, the data prop, its value is exactly the same, but the reference has changed because I think in this case we were creating all four of these in the render method, depending on a certain user setting. So every time the parent got rendered, then we had a brand new reference to a data property, and therefore it was triggering a re-render. So that was a very easy one to spot, to take outside the render method and make sure that that reference stays the same. Then, as I said, the flame chart, what we've found is that if the app is too complicated already, then suddenly this becomes very hard to actually delve down into what's causing the real problems. So you've got a whole kind of event container here with, I think these are 5 different rows in a flat list. And then you get right down to this very small level here. So the one thing it did help us spot, there was a kind of a periodic one that was appearing roughly every second with a long chain, and there was a timer that was running, and it was, the way it was set up, it was actually triggering the re-render of a lot of components that didn't need it. So we basically saw that periodic pattern, and that was quite an easy fix from using this. But as I said, the why did you update gave us some really quick fixes, because as we went on to fix these re-renders, we had a hunch it was probably going to be quite a big issue, or it was having a big effect on the performance. So again, I'm not going to go into too many details, show the code exactly how it happened, but these kind of React basics actually, if we went through and implemented them properly, and in places we didn't necessarily think they would be useful or important, we suddenly started to notice real performance improvements. So the pure components and should component update, they're the kind of obvious ones where, basically the new standard we have now is if your component only takes primitive types, then it's a pure component. And if it doesn't, you need a should component update. That's checking your objects or arrays for the important things that are updating. So with that flat list problem before, if the reference has to change each cycle for some reason, then maybe it's good enough to check that the length of the array has not changed, or you can check that the IDs of each element are still the same. So something like that. It depends on your implementation of it. Something else we spotted was reselect, so our crate selectors, we weren't necessarily using those correctly. We needed selector creators to make sure that each component had its own version of the selector, because again we had the same problem that the reference is changing, and to React that looks like that the world has changed and it needs to update. And another big one that we did a couple of weeks ago was upgrading React Native. So pretty much no work from us. We just upgraded React Native. Actually, it took a couple of days to actually get it working, but once it was working, suddenly these really kind of niche bugs where the password input was laggy the whole time since we'd released the app, and we just couldn't work out why, because it was no different to any other Redux component. And it turns out, one of the commits in the latest release is fix secure password inputs. So that fixed it for us without us having to actually delve into anything in too much detail. So that was, so our first cycle, we got very excited, fixed all these re-renders, and then we could tell it was getting better. Like you suddenly, that feels smoother. So, so we started at 38% janky frames, and then after that first kind of week of fixing the re-renders, we suddenly dropped down to, we were in the 20s, and suddenly the app started to feel really good, but still the number 20 felt quite high. So we decided to benchmark against the other apps just to make sure that we were measuring properly, or our benchmark was a valid one. So I think we measured Instagram, and that on my phone, which I probably is getting quite old now, had a 19% janky frame rate. So we weren't far off the apps we were used to. So we carried on going. We realized we were on the right track. So we could have fired up the why did you update again and fixed the remaining re-renders, which were still there. And suddenly we were down to some quite low numbers. I think the lowest we reached was 15%. We went up in the middle, we implemented a new feature and kind of forgot on new best practices. So I had to go back and fix them. But then, we're back down to 15%, and last week we were up to 17% for our key journeys. So, as I said, it's quite nice to actually see, okay, the changes we're making, they feel like they're improving the app, but also, we can be sure and we can go back and check in the future how it is, once we add this new feature, how it compares to 3 or 4 weeks ago. So 20% janky frames, 15% janky frames, that still means you're sort of quite a long way off 60 frames a second. When we started looking at it, we almost wanted, we have to be at 0%, we have to be 60 frames a second, and actually realized maybe that's not necessarily realistic on every device. I think it's kind of asymptotical. We're going to approach 60 frames a second, but I'm not sure an app will ever get there. But some of the really interesting things, like I said, this is only a kind of a junior method at the moment. But what would be really cool if we could start benchmarking on every pull request manually, automatically even, so you don't have to do it manually. So if each pull request is along with your tests, there could be something giving you an indication of the performance of how it's changed since you've made those code changes. So you'd have to somewhere fire up the app, run through a kind of functional test type thing with that janky frames measurement running. Another thing, like I said, I've only measured on Android. For a React Native app, that's probably fine. They're all JavaScript improvements, but it could be interesting to compare iOS and Android. Maybe we'll spot some big kind of implementation details on iOS that are still kind of slow that we haven't spotted on Android. Another one is maybe actually you just hit a bit of a brick wall, and that is a complex function. There's not much you can do about it. Maybe actually you can begin to adapt the UX of the app. You realize that, okay, that's as it is, you're not going to make it quicker. Maybe you can split two parts apart if it becomes that much of a problem. And yeah, the other interesting one is sort of begun to realise that although the app in general feels better, there is still the odd interaction that you do notice, the juddering and the janky frames. And because the measurement isn't average, so it's your average frames a second whilst you've been measuring your interaction, that kind of, it gets swallowed up in the average, and you don't see that there is this very slow kind of maybe half a second interaction. So it would be really interesting so basically getting more into the flame graph or using the Firebase performance traces to see how certain interactions that you know are slow, how they're doing. So yeah, I'll wrap up there. Thank you for listening. So like I said, yeah.